From harnessing the power of the atom to lighting up cities, nuclear fission has played a crucial role in shaping our energy landscape. But behind the bright lights and the promise of clean energy lies a complex and controversial history. Join us as we uncover the secrets of the nuclear age and explore the impact of these tiny atoms on our world. Nuclear power is one of the largest sources of clean energy in the United States and the world, accounting for more than 10% of the world's annual electricity generation. It is one of the essential components of maintaining a stable energy grid. However, nuclear power's history is composed of brilliant breakthroughs and devastating disasters, raising questions about the cost of harnessing the atom's power. Let us take a trip back to the early 20th century when the world needed new energy sources. With rapid industrialization and population growth, the energy demand was skyrocketing, and the traditional sources of energy, such as coal, oil, and hydropower, needed to produce more to meet the demand. Before the invention of nuclear power, most of the world's energy was generated by burning fossil fuels, such as coal, oil, and natural gas. Natural gas prices were high, and oil prices were even higher. Thus, the search for alternative energy sources began. Enrico Fermi, an Italian-American physicist, was the first to discover the strange properties of nuclear fission. By firing a neutron at a uranium atom, Fermi was shocked to discover that the elements left over were much lighter than the uranium itself. At the time, Fermi and his Jewish wife, Laura Fermi, were growing increasingly concerned with the rise of fascism in Italy. In 1938, Enrico Fermi was awarded the Nobel Prize in Physics for his identification of new radioactive elements and his discovery, made in connection with this work, of nuclear reactions affected by slow neutrons. Fermi then contacted American universities about employment opportunities. So when the Fermi family was given government permission to travel to Stockholm for the Nobel Prize presentation, they did not return to Italy. Instead, after visiting Niels Bohr in Copenhagen, they sailed on December 10th for the United States and Fermi's new professorship at Columbia University. At the same time, German scientist Otto Hahn and his junior colleague Fritz Strassmann later repeated the experiment using different elements. They concluded that the resulting atoms did not add to the original mass. These experiments were groundbreaking and set the stage for developing new atomic theories. Hahn is often credited with the discovery of nuclear fission. However, the story is much more complicated. Lise Meitner was a Jewish scientist who significantly contributed to the discovery of nuclear energy. Born in Vienna in 1878, Meitner studied physics at the University of Vienna, where she was the only woman in her class. A few years after earning her PhD in 1905, she met the research partner she would work with for 30 years, Otto Hahn, and they soon discovered several new isotopes. In 1938, Nazi Germany's takeover of Austria brought Meitner under German law, causing her to flee Germany and continue her work in Sweden. Hahn gave her his mother's diamond ring in order to bribe a border guard. She barely escaped with her life, managing only with the help of scientists both inside and outside the Reich. Meitner and Hahn continued to correspond secretly to discuss research. Meitner herself likely prompted Hahn's fission experiments. Upon hearing the results of Hahn's experiments, Meitner proved that the mass difference was due to energy generated during fission. Yet when it came time to publish, Hahn knew that including a Jewish woman in the paper would cost him his career in Germany. So he published without her, falsely claiming that the discovery was based solely on his experiments. However, Hahn had trouble explaining his findings, and Meitner had the explanation. So a few weeks later, Meitner wrote her famous fission letter to the editor. The letter was the first scientific publication to provide a detailed description of the phenomenon of nuclear fission. It helped establish fission as a natural and fundamental process, setting the stage for a technology that would rock the world. But when the dust settled, the Nobel Committee awarded the 1944 Nobel Prize in Chemistry for the discovery of the fission of heavy nuclei to Hahn alone. Arguably as important as any award or prize was Hahn's, Meitner's, and Strassman's staunch refusal to be involved in developing nuclear weapons, which their discovery had made possible. Despite their objections, the research eventually led to the Manhattan Project, a top-secret government program to create the world's first nuclear weapon. But it also laid the foundation for the peaceful use of atomic power. In the early 1940s, Fermi led a team of scientists at the University of Chicago to construct the first controlled, self-sustaining nuclear chain reaction. This experiment, known as the Chicago Pile 1, was the first time scientists could produce a sustained, controlled release of energy from the nucleus of an atom. Fermi's work on the nuclear chain reaction was essential in developing nuclear power. He demonstrated that it was possible to harness the energy released during nuclear fission, and that this energy could generate electricity. The first practical application of nuclear power came in 1951, when the Experimental Breeder Reactor 1, or EBR-1, in Idaho became the first nuclear reactor to produce electricity. The facility was built to test the concept of a breeder reactor, a reactor that reproduces some amount of fuel after using it. On December 20th, 1951, EBR-1 successfully lit 4 200-watt light bulbs. The next day, December 21st, the reactor generated enough energy to light the entire building and the lights outside in the parking lot. Although 400 kilowatts of power seems small by today's standards, it was monumental in 1951. This was the first time a usable amount of electricity had been generated using nuclear technology, and it paved the way for a viable new energy source. In modern times, while private companies still develop nuclear power plants in America, many raise questions about the costs of nuclear power. With disasters such as Chernobyl and 3 Mile Island, as well as the pileup of nuclear waste, it's understandable that the public would be worried about such an impactful technology. While these concerns are valid, the benefits of nuclear energy far exceed the costs. With a minimal carbon footprint and extremely efficient energy generation, nuclear power sets up a cleaner and safer future. The complex and controversial stories of Enrico Fermi, Otto Hahn, and Lise Meitner during the discovery of nuclear energy in the 1930s and 40s demonstrate the challenges and ethical dilemmas that arise in the pursuit of scientific advancement at the frontiers of knowledge. Their groundbreaking discoveries had far-reaching consequences, revolutionizing energy production, and sparking debates about the responsibilities and consequences of harnessing such a powerful and potentially dangerous technology. In a world so dependent on electricity, understanding its history will continue to be necessary. The scientists and ordinary people involved in the story of nuclear power will forever be remembered as those who pushed forth the frontier of energy.